Coming up in our classroom today, further analysis of the chain rule. We are going to be gaining in our classroom today more and more insight to the outside inside rule. This is SEP TV and you are highly welcome.
One white shoe and one nika.
Welcome back. Now, we have always understood that when it comes to differentiating the function of a function, there are shortcuts to that sort of business. Now, imagine that you had to differentiate this function, that you had to differentiate with respect to x, and then you're having x squared plus 1 all cube. What do? Let's go by the chain rule as we begin our lecture today. Now, this is going to be my inside portion, so I can simply come here and say let u be equal to, and then let u be equal to x squared plus 1. And this implies that du by dx, if I differentiate x squared plus 1, when you differentiate x squared, you are simply going to get 2x. This is simply 2x. When you differentiate 1, of course, you have 0. Perfect. Now, considering that we have achieved this, you now understand that y becomes equal to u. This is my u, all cube. Y becomes equal to u, all cube. Perfect. Now, if y is equal to u cube, what do I get when I differentiate y with respect to u? If I differentiate this sort of thing, I'm simply going to bring down 3 and reduce the power by 1. So I'm simply going to get 3u squared. Then we go on to state the chain rule. The chain rule simply states that dy by dx is equal to, we have dy by du, now multiplied by du by dx. Great. Now this becomes equal to, what is my dy by du? You can see it right here. We simply have 3u squared. Perfect. Now all this is multiplied by, what is my du by dx? You can see du by dx here, which is simply 2x. Very good. Now you notice something. This becomes equal to 2 multiplies 3 to simply give me 6. So I simply have 6. This is an x here. I have x. Then I have u all squared. So, but remember that at the beginning, we took u to be equal to x squared plus 1. So the answer to this problem simply becomes equal to 6x into, now what was my u ab initio? My u was x squared plus 1, so I simply have x squared plus 1 all raised to the power, now we have power 2. The question we are asking ourselves in the classroom today, how could we have done this thing? Because calculus is all about rules, like I've always said. Now, when you understand the rules, it becomes very easy for you to function. There are functions that will be given to you, and you just need some kind of a mental stability to be able to differentiate and analyze it immediately. Now, look at what we have here. We could have done this function, differentiated this function, by simply taking, now we can state the outside inside rule that d by dx of u to the power n. Now u in itself is a differentiable function of x. Now when we have u to the power n and we are differentiating that sort of function, You simply carry your n and bring down. You have your n, then you have u. You reduce n by 1. When you reduce n by 1, you simply have n minus 1. Then when you have done this, all you are going to do is to multiply by du by dx. Superb. Now, what exactly are we driving at? Now, what we are saying simply is, if I wanted to differentiate this function, this is simply going to be equal to, now if I'm to differentiate with respect to x, and then I'm having x squared plus 1 all cubed. It's simply going to be equal to, I'll carry this 3 and bring down. I simply have my 3. Then I'm going to repeat my u without touching anything as far as the u is concerned. That is u here. Then we are going to take n minus 1. N is 3. When I take 3 minus 1, I simply get 2. Now the whole of this multiplied by du by dx. That is d by dx. What was my u? Look at my u here. X squared plus 1. So I simply have x squared plus 1. Okay. Now look at the way it goes. This guy here is our n. This guy here is the u. Of course, this u is raised to a power n minus 1. And then this guy here is our du by dx. You see how simple it can be? So that's the way it is. What we are talking about in the classroom today is that for you to differentiate a function of a power function, basically all what you have to do is, if that function appears in the form u to the power n, take n and bring down. That is what we are saying here. Repeat u again, reduce that power by 1, and then you multiply by du by dx. Okay, so we are going to move over to solving the second problem, because when you simplify this, you are going to arrive at pretty much the same answer that we got here. So you get the same answer here when you simplify this. Of course, when you do this, you get 2x. That 2x multiplies 3 to give us 6x. And then that 6x is what you're seeing here. And then you now have this. So you get the same answer. So let us look more into some of these problems that we have to solve. How can we solve these problems? By applying, now we are asked to differentiate, we are asked to differentiate with respect to x, and then we are having x to the power 4 plus x cubed, all raised to the power 1 over 3. We are going to make use, we will be applying the inside-outside rule, or the outside-inside rule. This is the inside, and then externally is the outside. So you can imagine this to be your u. The very first thing I am going to do, take this power and break it down. So I'll simply have 1 divided by 3. Now you are going specifically, instead of having to go through the long and boring chain rule. Now when I do that, I'm going to repeat my u here. I'll have x to the power 4 plus x cubed. Now all raised to the power, I'm going to reduce this power by 1. So let me just write here 1 over 3 minus 1. Then the whole of this is multiplied by d by the x of the inside now of x to the power 4 plus x cubed. So that sort of thing. Okay, perfect. Now this becomes, I want to do something here. I want to understand, let us quickly do 1 over 3 minus 1 over 1. LCM is 3. 3 divides 3 to give me 1. 1 multiplied by 1 gives me 1. Minus 3 divided by 1 gives me 3. 3 multiplied by negative 1 will simply give me negative 3. So I have negative 3. 1 subtracting 3 will give me minus 2. So at the end of the day, I simply have minus 2 all over 3. Thank you. So So what I'm trying to say is that when you evaluate this, you get negative 2 over 3. That's what we just showed down here. So at the end of the day, this simply becomes equal to 1 over 3 into x to the power 4 plus x cubed. And then we got negative 2 over 3 for minus of 1 over 3 subtracting 1. Perfect. Now multiplied, we are now multiplying by when you differentiate x to the power 4. This is now where we are going to perform the differentiation. When you differentiate x to the power 4, you bring down 4 and subtract 1. Now when you do that sort of thing, you're simply going to get 4x cubed. And then when you differentiate x cubed, you're simply going to get 3x squared. Okay? So we have 3x squared. And we close. So basically, this is the end of the problem. All what we might have to do is just to arrange. We can just arrange. Now when we arrange, what happens? This is minus 2 over 3. It can come down. So we simply have this being equal to 4x cubed plus 3x squared, which is this factor here. Now divided by 3 into, then we have x to the power 4 plus x cubed, all raised to the power. Because this has come down now, the power now changes to positive, and then we simply have 2 over 3. So this becomes the final answer. This can become the cube root of the whole of this all squared. So, but that's not basically what this class is meant for. This is a calculus class. Look at where the focus is to be able to do this thing and handle it accurately without making any mistake. Now let us look at question number 3. As usual, I'm going to stop at this problem, and then you would have to continue and do the last one and let me know what you think about our class today. Okay. Alright, so we are asked to differentiate d by dx of the cube root of x squared minus 1 all squared. What do we do? Now from indices, this is the same thing like you are differentiating with respect to x. We have x squared minus 1. Because of this 2 here, and this is cube root, so this simply becomes to the power 2 over 3. You can look up for my videos on indices where I am analyzing this sort of thing, or this kind of thing. Okay, so it becomes 2 over 3. This. So the power here is 2 over 3. We will still apply the outside-inside rule. It's faster and more specific. It gives us what we want. Now, how do we do? What do we do? Well, the first thing we are going to do, we carry this power and get it down here. So this becomes equal to 2 over 3. I'm going to repeat this because this is my u. This guy here is my u. So I'm repeating him again, x squared minus 1. Then when I have done that, I will reduce this power by 1. I have 2 over 3 minus 1. Now multiply by the derivative of this guy. Multiply by d by dx of x squared minus 1. Is that okay? Now this becomes equal to, let us try to know what 2 over 3 minus 1, because it might be a little bit confusing. So let's just know what it comes out to give. 2 over 3 minus 1 over 1. LCM is 3. 3 divided by 3 is 1. 1 times 2 is 2. 3 divided by 1 is 3. 3 times negative 1 is negative 3. So 2 minus 3 will simply give us negative 1 over 3. So when you evaluate 2 over 3 minus 1, you get minus 1 over 3. Okay. So what then happens? This becomes equal to 2 over 3 into x squared minus 1. And then when it comes to this power, we just did that some kind of arithmetic there, and we discovered that it gave us negative 1 over 3. So we have negative 1 over 3. Now we are multiplying by the derivative of x squared minus 1. When you differentiate x squared minus 1, take this 2 and bring down and subtract 1. So we simply have multiplied by When you differentiate x squared, you get 2x, and when you differentiate negative 1, you simply get 0. Okay, perfect. Now look at something. These two, we are done with the differentiation here. It's just for us to use algebra and make our answer a bit more presentable. Now when you carry this 2 and multiply this 2, you are going to get 4. Okay. So we simply have this being equal to 2 multiplies 2 gives me 4 all over 3. And then we have x, which is this x here. And then into x squared minus 1 or raised to the power negative 1 all over 3. That's the end of the problem. Voila. So you are going to have to do question number 4. Very simple. This is 3x minus 2x squared all raised to the power 3. Take this your power, get it down. Repeat this, minus this, subtract, reduce that power by 1. And when you have done that, you then differentiate the inside. Thank you so much for staying tuned up until the end of our classroom today. Please, just in case you have not subscribed to SEP TV, you can do that right now. Do have a wonderful time. Bye-bye.